Hi, this is Lance at Acroname. In this guide, we're going to talk through getting started with Brainstem MTM and an initial evaluation of the technology. In previous guide that we have published goes through the hardware setup of an MTM evaluation board, and in this guide we're going to walk through an initial bring up and basic evaluation of the Brainstem MTM platform. By the end of this guide, you'll be able to use USB to access MTM modules over the Brainstem network, use the Updater command line tool to update your MTM modules to the latest firmware, and use STEM tool to exercise simple functions using resources of the MTM modules. We'll go through several examples. In this example, we'll go through the exercise with Windows 10. Here you can see our Windows 10 desktop, and what we're going to do first is to download the Brainstem Developers Kit from the Acroname website. So we'll go to acroname.com/software and we'll download the Brainstem Developers Kit from there. The Brainstem Developers Kit or BDK directory is going to be placed on our desktop for easy access. Now that we've downloaded the Brainstem Developers Kit, we'll go and we're going to have to expand the compressed file, so we'll expand it right to our desktop. With the Brainstem Developers Kit open, we can see several directories. In here first, we'll go into the driver directory. If you're using Windows 7, you'll need to pay special attention to the Brainstem USB drivers, which you'll need specifically under Windows 7. Under Windows 10, we don't need them. The other programs we'll be using in this exercise will be located in the bin directory, and we'll be using the Updater command line tool and the STEM tool GUI for our evaluation exercises. Next, we'll take our evaluation board and we'll give it power from the 12-volt power brick supplied with the kit. We'll also plug in USB from our host Windows 10 PC into one of the edge connectors on an MTM module. In this case, we'll use the MTM USB stem. Now we'll use the Updater command line tool to update firmware in our module. We'll open the command line in Windows 10 and then use the Updater command to discover MTM modules connected to our host. We'll go to the proper directory and we'll see the Updater tool. Then we'll type Updater-D to discover the attached modules in our host. Once we have the serial numbers of the modules available, and we only have one because we're plugged into just the MTM USB stem, we'll copy that serial number out. And then we'll type Updater-G-U-d and then the serial number to update that module. The Updater program will now go up to the Acroname servers, get the latest firmware, and update the module with the serial number that we indicated. Once that action is done, the module will reset itself and the new firmware will be installed. Now that the firmware is updated in our module, we can go ahead and connect a jumper wire from one of the digital pins to another one of the digital pins. We'll use this as our first exercise to show a digital output being toggled back and forth from logic high to logic low, and a digital input to read that value. So use STEM tool to exercise the MTM USB stem. You'll see first under STEM tool that on the left-hand pane we can see the modules that have been discovered in the STEM tool utility. We see MTM USB stem over here. The heartbeat icon indicator shows that the STEM tool UI is communicated with the MTM USB STEM module. You'll also see a section on the bottom that covers the digital and the analog sections of the module. For this exercise, since we jumped from digital 0 to digital 7, we're going to turn digital 0 into an output, and we can toggle it back and forth from being logic high to logic low. We should see that reflected over on the digital 7 pin, which is still set up as an input. Next, we're going to exercise an analog input to read the voltage from one of the digital pins. So we're going to connect digital 1 over to analog input 0 on the MTM USB stem. We go back to STEM tool, and you can see that if we set digital 1 up to be an output, that voltage on digital 1 should be reflected on analog input 0. We see the analog input being pulled down to 0 since the output is pulled low, and now we can see the analog input pulled high for logic high level. Now we'll use a third exercise to measure an analog voltage, set an analog voltage and read an analog voltage. We use the orange jumper to go from the analog output of the MTM USB stem to analog input 1. In the STEM tool utility, you can see as we slide the bar for the analog output, that analog input 1 will move correspondingly. We can also use the input value to put a voltage in that we would like to see show up on the analog output. This should also be reflected on analog input 1. For our next exercise, we're going to jump across from analog input 2 over to the back side of the power module, and we're going to read rail 0's power output. You can see where we're tagging down on the MTM development board. We're actually connected to the Kelvin sense output for rail 0. In this exercise, since we're using the MTM PM1 module, we want to discover that on the brainstem bus. So we use the route to me function to discover the PM1 module. Once we're communicating with that, we're going to go ahead and enable the Kelvin sense feature, and then we're also going to enable rail 0. This should be reflected on the USB stem analog 2 input because that's where we have it wired. Now we can go back to the MTM USB stem, and we should see the 1.8 volt default value of rail 1 reflected on that analog input. We can go back to PM1 and we can change that voltage output to whatever we like numerically or with the arrow keys. If we go back to MTM USB stem, we should also see this reflected on the analog 2 input. Congratulations! You've now completed your first exercises with MTM module functionality. If you have any other questions, please feel free to contact Acroname support at support@acroname.com or Acroname sales at acroname.com. Thanks and have a great day.